Good morning, students. After studying Newton's Gregory forward-backward interpolation formula and divided difference, I would like to continue with the topics of Module 5, that is numerical solution of algebraic and transcendental equation. Now, what do you mean by algebraic and transcendental equation or function? An algebraic equation is the one which consists in them a polynomial equation like x cube, x square, so on. An equation having other than the polynomial is called transcendental. For example, an equation involving exponential, that is e power x, or trigonometric function tan x or cos x and so on is called as transcendental equation. Generally, any polynomial equation can be solved, that is the roots of a polynomial equation can be found out either by factorization, syntactic division, or also using calculator. But how do we find the roots of an transcendental equation is what we are going to study in the Newton Raphson method. Here is what I have explained what is the graphical derivation of the Newton Raphson method. For this, the graph is given in the next slide. Now, as explained in the previous slide, there is a graph here, and from the graph, considering the triangle ABC, tan alpha is given by AB by AC. In the next step, tan alpha is replaced by f dash of x naught is equal to f of x naught by x naught minus x1, because tan alpha is equal to dy by dx, which is nothing but the derivative. And simplifying further, we obtain x1, that is the first iterating formula, is equal to x naught minus f of x naught by f dash of x naught, where x naught is the initial value of the function where the root lies. This is the general form of the Newton Raphson method. That is, for the nth point, xn plus 1 is equal to xn minus f of xn upon f dash of xn. Now, how to use this formula will be better explained by solving an example. Generally, when the example is asked to solve by Newton Raphson method, the root x naught will be given. In case the initial value x naught is not given, how do we need to find it out? For that, the first step will be consider the function f of x. Starting from the positive value of x, that is any value 0 to any value, find f of a and f of b such that for one value of x the function is negative, and for the other value of x the function is positive, because the intermediate value theorem says that if a functional value lies in between one negative and one positive, then the root lies in between those two values. That is, then there exists at least one point, that is root, say x lying between a and b, such that x lying between a and b such that f of x is equal to 0. Now here I have given a bisection method to find the initial value x naught. That is, if for a x is equal to a, f of a is negative, and for x is equal to b, f of b is positive, then the first initial value x1 or x naught is equal to a plus b by 2. If f of x1 is equal to 0, then x1 will be the root of the given equation. Otherwise, the root lies in between x1 and b.